Okay, so we're recording now, and I imagine everybody can see. I'm gonna try to make this a little bit more well organized. Okay, that's fine. And okay, let's go to practice, and we go to Monopoly. And can somebody chat me really quickly, because I don't see the chat control here. Oh, there it is. Boom. Okay. Okay. I think that'll be fine. Okay. So on the Monopoly homework, do we have questions? Because we really didn't get to the point where we were talking about Monopoly. And we probably have a few more things to say about competition too, but I think it's time to move on to Monopoly. So let's just do a couple of questions to kind of warm up. And so let's do, because these questions should be pretty straightforward. Let's do questions 1 and 2 on this Monopoly practice problem. Okay. Can everybody see it? Okay. Thumbs up. Yes. Okay, you guys. So I'll let you guys work on it for a few minutes, and then we'll come back and talk about it. Okay, so I'm back, and do we have any responses for question number 1? Anybody want to raise their hand and want to say that they figured it out? Or how about this? Oh, okay, Eduardo raised his hand. Anybody else? Okay, Eduardo, You have your mic? You want to tell us what you did? Okay. Hey, by the way, it's really helpful if you guys get a mic and you can participate that way. The other thing that I think that you can do, I've not done it, I just seen it as an option, so you could play around with it a little bit. But I know there's a way to join the audio with your cell phone. And so maybe you can, figure out how to join the audio with your cell phone, and then we can hear you. So who had their hand up? Was it Roberto? Right, I didn't say, or Ruben, maybe. It just, on my side, it just flashes really quickly who raises their hand. So, oh yeah, Ruben, you were number 2. You want to explain to us what happened or what you did?
For question 1, what you have to do is to set up marginal cost equals marginal revenue. So that will be 10 equals 231 minus 14Q, and then you solve for Q, and it would be 15.79.
Okay, yeah. So I agree with you, and I don't know if everybody heard or not, but I can put a little annotation here. So yeah, you're setting marginal revenue equal to marginal cost to find out the monopolist level of production. And the only thing that is, maybe like a little bit of a trick, but it's not really tricky, but you got to remember that whenever you have this linear description of demand, then marginal revenue is equal to has exactly the same equation with twice the slope. And that's something we'll explain a little bit later, because there's a reason. Marginal revenue doesn't always look like that. If you don't have a linear demand curve, it'll be different. So we have a more general formula for any type of demand equation to calculate the marginal revenue. And so, Ruben, you were saying that if we set this equation equal to the marginal cost of 10, and we solve for it, then we'll get this answer. I'm trying not to turn off my annotation. So is that the answer you got?
Yes.
Okay. Anybody have any questions about that? No. Okay, so Ruben, why don't we stick with you, because I imagine you did number 2 also, right?
Yes.
Yeah, and so what did you get for number 2?
120.47.
Okay, and how did you get that?
You plug in the quantity that we just found, 15.79, into the inverse demand function.
Right. So I hope everybody heard that. This is kind of the thing that makes Monopoly a little bit different, is that in terms of finding the monopoly equilibrium, there are really 2 steps. And the 2 steps are that you find the monopoly quantity, and then you have to take that quantity and plug it into the demand equation. And Ruben properly spoke to the inverse demand equation to be technical and accurate. And then you find the corresponding price. So, and is this what you got, Ruben?
Yes.
Okay. So, okay. Ruben. Okay, good job. So, is there anybody, let's, I guess, as we move a little bit more down here, so we all get the idea, and so we should be able to, and let me see if I can, I'll turn my annotations on and I'll erase that. Okay. Okay, and so there's producer surplus, and so we should be able to do 3, 4, and 5 with no problem. So let's go ahead and do those now, and then I'll come on back to you guys. Do 3, 4, and 5. Okay, I didn't hear anybody say that you're done yet. So I'm a little bit concerned. So here's the I don't know if you guys are still working. So how many people are still working? If you're working, raise your hand. Okay, Greg, Efren, Noah. Okay. Okay. So, okay. Keep working, then I'll give you guys a few more minutes. And then remember, type done in the chat when you're done. Okay. Okay. So a bunch of people have said, or anyway, more than one or two, that they're done. So let's go ahead and if you're done and you have a mic, go ahead and raise your hand. Okay. Nia. So why don't you go ahead and tell us about number 3 and 4. Okay.
So okay. For number 3, for the price minus the marginal cost divided by the quantity, and so the price for number 2 is 147 and minus the marginal cost, which is 10, and multiplied by 50.79 is the quantity we got for the 1, and I got 1,744.32.
Okay. So I don't know if it was you or if it was me but you kind of roboted out a little bit and faded. So
it might be me because my Wi-Fi is a little spotty.
Okay, so I heard you more clearly that time. So why don't you say it one more time? Say it loud, say it proud.
Okay, so surplus is price minus marginal cost times quantity. So okay. I put price from number 2, which is 1.47 minus the marginal cost, which is 10, and then multiply that by the quantity from number 1, which was 50.79, and then I got 1,744.32.
Okay, so I think I heard it. But yeah, I think maybe it's your internet connection a little bit. By the way, what I did, and I hope mine's fine, but I ended up plugging into my router. So I don't know
okay.
if you guys,
I'll try that out then.
Yeah, I don't know if you guys have a cable to do that or not, an Ethernet cable. But luckily, I've played a lot of Call of Duty online, and if I don't have the cable, I know the screen goes and I'm dead, and I don't know why. So yeah, unstable internet connection is something I've handled. So Okay, so is that your answer? Number 3.
Yes, that's my answer.
Okay. And I know kind of, again, there was a little bit of robot involved there, but I'll ask, so Celine, you had your hand up and you said you have a mic too. Do you want to chime in, and did you get the same answer?
I got the same answer. Can you hear me?
Yeah, I can hear you.
Okay, I got the same answer, but I took the marginal revenue minus marginal cost, and then I took the integral of that. But I got the same thing, so.
Okay. Marginal revenue minus marginal cost and the integral. So my brain's kind of, see, because we don't use calculus in this, I have to really think about the areas, and it makes me a little bit nervous. So, because that seems like that's a lot of heavy lifting. But yeah, I don't know if you can explain it more simply than that, because I would explain it in terms of area. And so let me show you guys. So again, you know, I'm a big, because even if you're going to do integrals or something like that, I'm a big fan of drawing a picture, because at least then you can see the area that you're going to integrate. So and you know, all it has to do is be a reasonably accurate sketch. You know, it doesn't have to be super precise. I don't know if this is giving me a little bit of a hard time. Okay, there we go. So there's demand, and there's the marginal revenue there. And then we have a constant marginal cost. And then hopefully you guys can see that where this, and I could annotate it further. I don't know if there's anybody who can't see. So this is the marginal cost, and the steeper downward sloping line is the marginal revenue. So the monopoly quantity, I'll say QM, would be there approximately. The only reason why I'm not drawing the intersection, and the intersection that I'm talking about, okay, it was just being weird a minute, because I don't know why it's trying to ask me about accessibility preferences. This is okay, whatever, because all I'm trying to do is annotate. But I'll try to just hover my mouse. Can you guys see the intersection of the marginal cost and the marginal revenue? That's the quantity I'm talking about. And then directly up from that, from the demand curve, that's where we would find the monopolist price. So I'll put PM there. Okay. So in this case, and I'll draw it in a, I guess a different color. So here's the monopolist price, and well, it was meant to be a different color. So oh, it didn't want to change the color for me. Okay. Then so here's the monopolist price. And so question 3 is asking us how much producer surplus is created. And so the producer surplus should be this area in here. There. It's above the marginal cost, and so maybe I can highlight this area in here. So it should just be PM minus MC. So we had the price before, and so we had 120.47 minus 10, and our QM was 15.79. So you guys can put it in your calculator and let me know. But my calculation would be producer surplus is equal to PM minus MC times QM. So Celine, is that basically the calculation that you performed?
Yes.
Okay. So and you got the 1744.32 approximately. Yeah. So does anybody have any questions about that one? Does everybody see how it was done? Okay. So thank you to Omnia and Celine. Okay. And I will delete that. So how about for numbers 4 and 5? Okay. Numbers 4 and 5. And do we have any volunteers? Raise your hand. Okay, so Greg, you have your mic on?
Question about 4. I think it's the same as number 3. Wouldn't the equation be the same for profit?
Well, let's look. Ooh, they're not the same. Right. So okay, yeah, exactly. So Jin is right, if you guys can see in the chat. So you guys say that it cut out, but are you talking about I cut out, or that there was a little problem for Greg, or the other Greg?
I could hear you fine. I don't know if they can hear me.
Okay. Well, anyway, we soldier on, and so the difference, and this is kind of, you know, a little bit of a learning point, and you know, something you guys will find useful later. So producer surplus is related to profit, but if you notice, Greg, right? So on each of these units, you're paying their marginal cost to produce them, right? and you're receiving the price from the seller. So it's kind of like your markup on each unit, right? Do you hear me, Greg? Are you there?
Hello?
Yeah,
Hello?
Greg, are you there? Can you hear me?
Yeah, I can hear you. Yeah.
Yeah, so it's like your markup on each unit, right?
Yes.
Yeah, so this is like your total markup on all the units you sell, right? But that's not your profit, is it?
No, there's still fixed costs.
Yeah, you still have to pay for your rent and stuff like that. Just because, I mean, if you think about it like a retailer, just because you're able to, purchase your units at wholesale for $5 and you can sell them for 10, sure, you're making $5 on each unit. And if you sell 100 units, then you made $500. But you still got to pay your rent for your little kiosk or whatever, right? In order to calculate your profit, you still have the fixed costs. So the relationship is that, and this is one that, I mean, there's a lot of different ways to get it, but your profit is also equal to your producer surplus minus your fixed cost, right? So now you can see the difference between these two answers is just the amount of the fixed costs.
Got it. Thanks.
Yeah. And hopefully it's intuitive because of the way that I explained it, but it should make sense. Again, if you think about it a little bit, and that's why I say it's a learning objective, because as you get a little bit better with these ideas, interpreting what's on the graph and what they mean, then the other stuff will kind of occur to you. You'd be like, yeah, of course, this can't really be just profit. The thing that if you really wanted to describe producer surplus, you would call it marginal profit, because it's the additional profit if you get additional producer surplus, right? So the change in producer surplus is equal to the change in profit. That's true. But yeah, it's not exactly the same thing. That's why I dance around the concept a lot when I'm first explaining it to students in principles of economics, because it's really like you want to say it's profit, and it almost is, but it's just not quite. So okay, so so we did number 4, and okay, this one should be pretty straightforward. What about number 5? Who wants to? It's not phrased as a question, Jin. You said you can say gross profit in accounting, and I would say no, you can't say that, because we're always talking about economic profit, and so our marginal cost concept is different than any real concept in accounting, because it's not like full opportunity cost type thing. But hopefully you guys get the idea that if you're going to try to measure these things as a practicing economist, you have to be very careful, because oftentimes the only real source of data that you have is accounting data. And so, your estimates are going to be off a little bit, and that it's not something I can really tell you how to handle within the scope of this course, because it's like outside. But if you're doing things econometrically, you got to be careful in constructing your estimates. So let's go on and go to deadweight loss. Does anybody have a hand on deadweight loss? I see Omnia's hand is up, and I'm gonna look and see if anybody else wants to talk about deadweight loss. Okay. So I'll pick somebody at random. Okay, Andrew, are you there? Andrew? Okay, I don't, Andrew. Okay, how about you, Danny?
So I got 1 through 4, but I'm not too sure how to do the deadweight loss. I have the graph partially done. I mean, partially done, but nothing else.
Yeah, okay. So you can see my little graph because I just drew it, right?
I have some numbers on mine.
Yeah. So what area would we be talking about for the deadweight loss?
Your mouse just left it.
Yeah. Okay. So I'm gonna change the format here, and I'll try to highlight it. So we would be talking about this area here, this triangle, right?
Yeah.
So, but this is an important point because what you have to do in order to calculate that area of the triangle is you also have to know what's QC. Now it's not labeled here as QC, but in this sort of simple example, remember that the marginal cost curve is the supply curve for competitive firms. So it's the best way to answer this is you have to calculate the competitive equilibrium and to calculate the base of the triangle. So did anybody do that and calculate deadweight loss that way? If you did, go ahead and, okay. So Ruben, why don't you tell us what you got?
871.61.
Is this what you got? Okay.
Yeah.
Yeah. So if we did that, then that's what we would get. Does anybody have any questions about that?
How did we get QC?
Well, so you have the marginal cost, that's 10, and you have the demand equation. So just like we calculated the monopoly equilibrium, we can use setting demand equal to 10 to calculate QC.
Cool.
That makes sense, Danny?
Yep. Thank you.
Sure. You're welcome. And so the last one here, number 6, is the consumer surplus. Anybody have that one? So Ruben raised his hand. Anybody else? I'm looking for somebody. What about you, Aubrey? Are you there?
Yeah.
Did you do it?
I'm kind of confused. I'm not really sure how to do it.
Okay. Well, do you see the graph that I have there?
Yeah.
Right. Can you see what you think consumer surplus would be?
Consumer surplus would be the pink square, no?
No, because okay, I'll give you guys more time, like the verbal definition of consumer surplus. So consumer surplus is always the area below the demand curve and above the price that consumers pay. So in this example, that would correspond to that would correspond to this triangle here.
Hmm.
Do you see?
Yeah.
And just so you guys know, this example is supposed to be super simple. So Aubrey, now that you know what it is, can you calculate it for us quickly?
Yeah, I think so.
And you guys can see my graph here, and you can see the yellow area is consumer surplus, the pink area is producer surplus, and the green area is deadweight loss. But this is like as simple as it gets, and that's the reason why this question is on there, is to just kind of like, you know, orient you, help you remember stuff that you remembered and that we covered in principles that you guys probably should remember. And you know, this is like a graph you should just have stored in your head someplace that you can, you know, regurgitate, reproduced whenever, you know, is needed. Because again, it's one of those things that will help orient you as you work through these problems. So, are you done, Aubrey?
No, I can't find the number for what PM is. I lost it in my notes. I'm sorry.
Okay, well, I'll help you then. So we have this is, so I think it's so what price here, number 2. So we have 120.47. That help you?
Yeah.
Okay. And our QM, just so you remember, is 15.79.
I got 872.63.
872.63. Is that right? Did I type it in correctly?
Yes.
Okay. And yay! Yay, Aubrey. Okay, good job. Okay. So, does anybody have any questions about this stuff? Okay. Now, I just want to talk really briefly about the remaining questions. So, what we did up until this point in time is we talked about the monopoly equilibrium, and in the very last part, when we talked about deadweight loss, we considered the competitive equilibrium, and that's always our benchmark. So these other questions are asking you, well, if this was a competitive market, what would the consumer surplus look like, right? And so, you know, how much will the monopolist owe? Well, I guess this one's a different one. Now we have an upward sloping marginal cost curve. So things change a little bit in these remaining questions, but just, you know, the substance of the equation is the same. It's just, or the question is the same. It's just the equations are different. So, okay. Does anybody have any questions for me? Okay. So I'm gonna go ahead and shut this down and get us a whiteboard. And if you guys have a question, you can either raise your hand, or you can unmute your mic and start speaking, or you can put something in the chat. And then we'll go ahead and we'll go on. Okay. So even though I would very much like to move on completely and start talking about other things to do with Monopoly, I still think that in terms of what we're going to do for the lecture next, it would be a good idea for us just to solve one of these questions that has the upward sloping marginal cost curve before we start lecture. So let's go ahead and do number 8, and I'll let you guys work on it and give you just a few minutes, and then we'll come back and we'll talk about it. Okay, so let's work on number 8 for a few minutes. Okay. So, Jared, we haven't heard from you yet. You have your mic there? You want to tell us what you found out?
Yeah, do you just want the answer?
Well, you can tell us what you did, and then.
So I took the 650, and then I took the 13Q and I doubled it to get 26, to get 26Q.
And that's the marginal revenue, right?
Yeah. And then I set the marginal revenue equal to the marginal cost and solved for Q.
Yeah. And is that what you got?
Yeah. 20.61.
Yay, Jared. Good job. Everybody else is clapping for you too. You can't hear them, but it's just there's a crowd of people clapping. Okay. So this is a good point. Thanks very much, Jared. Yeah. John clapped. Good job. So okay, so now I want to talk a little bit about these problems down at the bottom of this homework, because like I said, these were the ones that were more challenging, and we talked about this a little bit last time. So I'm going to go ahead and put up our whiteboard, and then we'll go from there. So, okay. So the first thing that I want to talk about is where does the marginal revenue come from for the monopolist? And so remember that our total revenue, and so I'll just write revenue, is equal to the price of our product times the quantity that we sell. So that's just generally true. And so but for us, remember, using the inverse demand equation, we have something like P in this case, and we'd labeled it PB because it's the buyer's price. But I just want to emphasize to you guys that it's the same equation. And it's something like A minus B times the quantity demanded. Okay. So if we go ahead and we substitute in for the revenue equation, we can write revenue, and now I'll abbreviate. Revenue is just R. It's total revenue. It's going to equal to A minus B times Q, and then we're going to multiply the whole thing by Q, right? So we can go ahead and expand this equation by distributing the Q over the terms in parentheses and get A. And now I'm just going to do away with the stars. You guys should know AQ is A times Q minus BQ. And I'll use the little caret to mean Q raised to the second power. So it's Q squared. Okay, is everybody with me? Any questions? Okay. So then remember, the definition of marginal revenue is equal to and I'm just gonna write D for the derivative, dr divided by dq. And if that derivative language confuses you all, just remember that the little d there, right, just simply stands for change in, right? So it's like the capital Greek letter delta is what we would use for finite changes, as opposed to the derivative, which is infinitesimal changes. But conceptually, they're nearly identical. And so for our purposes for this class, you know, it doesn't matter. Now, the one thing, and I said that you guys don't have to know calculus for this class, but if you don't know calculus, you still have to memorize some formulas that are derived from the calculus. So in this case, note that I could rewrite this, and I just want to emphasize that that's a times q raised to the first power, right? Minus b times q raised to the second power. And whenever we have an equation that's a polynomial like this, we've got terms that are raised to the first and second power, then we can calculate the change. So if we had a general function, f is equal, and I showed you guys this before, well, some coefficient a times x raised to the b power, right? Then if we want to calculate the derivative of that, or the change in f with respect to the change in x, so if I want to calculate df dx, then there's a really simple formula, which is I'm going to not do anything with a, but I'm going to take a times b, right? And then just to kind of emphasize that things are separate here, I'll put asterisk or a little star there for multiplication. But remember, AB is a times b, okay? And then we have x raised to the b minus 1 power. So that there is your general formula for calculating changes that you got to remember for this class. And we talked about it also in the context of the consumer choice problem. When we're calculating marginal utility, we use the same formula with the alphas and the betas and so forth. So in this case, what you'd end up with is, and I'll go back to, is that our marginal revenue is going to be equal to, now you've got the first term, which is raised to the first power. So if, you know, I was going to write this out, it would be 1 times a, which is just a, right, times q raised to the 1 minus 1 power, right? And then the second term, we would apply the same formula, and it would be 2b times q raised to the 2 minus 1 power. So, and I'm sure all of you guys that have had calculus have already seen this type of stuff before. But remember that you got to be good with your exponents too. That's algebra. It's not calculus. Like I said, and I will be the first person to admit that calculus is easy, but algebra is hard. And so likewise, trig is hard too. Because with algebra, and I'll just emphasize algebra because in our case, we need more algebra than we need trig. But in the case of algebra, right, it's completely unforgiving. If you make a simple mistake, if you forget anything, you know, it's just like other areas of math. But with calculus, normally you're just doing like one computation, whatever. But now you got to remember all your algebra rules, get everything right. But anything to the 0 power is 1, and you guys probably aren't used to applying that, you know, q to the 0 power, where q is some variable, you know, but regardless of what value it takes, it's going to be raised to the 0 power, so it's always going to be 1. So we can just write A times 1 is A minus 2B Q, and now it's Q to the 1 power, so we can leave it out. So you'll notice, now let's see if it's going to let me. You'll notice the marginal revenue here, right, is our demand equation, and the only difference is that it has twice the slope. It has 2b instead. So we're really lucky. And like I said, you have to memorize this relationship. But the other relationship that you should memorize is that more generally, the marginal revenue can always be calculated this way. If I had some other inverse demand equation besides this, I could still calculate revenue this way, and I'd get some other functional form, and I could take the derivative of that and calculate marginal revenue. And there are other ones too, and occasionally when we had a little bit more time, and this was divided into 2 classes, I would spend a little bit of time showing you guys other forms of inverse demand equations other than the linear one. But you know, that's one of the topics that kind of got dropped as we moved to the semester from the quarter system. But if you remember this, then you shouldn't ever run into any trouble. Okay, so I'll ask you guys really quickly, do you guys have any questions about that? Okay, so then let's go ahead and look at a new whiteboard. And remember, for the monopoly equilibrium, the monopolist wants to maximize profits, right? Just like the competitive firm. The difference is that now if we look at the profit equation, I got to come up with a good abbreviation for that. I'm just going to call PFT profit, right? So we have total revenue minus total cost. And I'll just write it out for a minute, and then I'll abbreviate after that, just so you guys know what I'm talking about if you go back and you review this. So total revenue, we know, is going to be P times Q. And then more generally, we're going to have a cost function that's some function of Q, right? So remember, in the case of the competitive firm, this P was a constant. So this is what's different, right? The competitive firm, and I'll put it over here too, and the competitive firm also has the same objective. But what's different in the problem is, and I'll see if I can go ahead and stretch this out a little bit to give us some more room. And so what's different is that for the competitive firm, P is a constant. It's the competitive market price. And so in that case, right, so for the competitive firm, P is equal to P star, and I'll put IE, which means in other words, the market price. So this is where the assumption that, and I'll put here, that the competitive firm is a price taker comes to play. And I'll move things around a little bit more and give us a little bit more room. Okay. So this is why the price taking assumption is important, because it gives us some justification for what's going to happen next. And the other thing that's kind of worth pointing out here for a minute, and I'm going to come back to this screen, but I just want to draw you guys a little picture first, is that the way that the profit function looks, let's see if I can get this to do what I want it to, is generally the profit function is a hill like this, and that would be a smooth curve if I was better with the mouse. So here we would be graphing profit, and here this would be the quantity of output. And so again, if you guys remember from calculus, what we're looking for is a description of, and well, let me delete that and go again and try to get, we're looking for a description of the peak of this hill. And the peak is, notice here the slope is positive, here the slope is negative, and so at this peak the slope becomes 0. That's why I drew a horizontal line, because the horizontal line has a slope of 0. So the tangent line will become 0 at the peak. And so and maybe it's better if I use an arrow here, but so that peak is going to happen at our profit maximizing quantity, so at Q star. Okay, so now I'll go back to this equation, so the profit equation, and so how do we find the slope of the profit equation? Well, that's taking the derivative, right? And so we're going to compute d profit dq, and again, in the case of the competitive firm, since P is so I'll put for the competitive firm, since P is a constant, remember that's Q to the 1 power. So we just end up with P minus, and the derivative of the total cost function is the marginal cost, is equal to 0. That's what we're looking for, okay? So when dPFT dQ equals 0. So the main point is to emphasize that, and let's see if I can stretch it out. Well, maybe it's better. Okay. Okay, so the point is that this, where we're putting P minus MC equals to 0, that 0 is something we're introducing into this equation. The left-hand side here is just a general description of the derivative of the profit equation, and we're deciding to set it equal to 0 because we're looking for the Q that satisfies the slope of the profit equation being equal to 0, because we know that's where the peak is going to be. So it's just important, for your thinking, that you guys understand, what's an assumption that's behavioral and what's just pure math. And so you guys can see the conclusion for the competitive firm. That means, the competitive firm will choose P equal to MC. And we've already seen that. So for the monopolist, what we saw is that the derivative of the profit function is different because P is a function of Q, right? So depending on the quantity that the monopolist chooses, the price is going to actually change. So when we compute that derivative, and you guys, if you guys have had calculus, you've seen this before. We could have a general, P function and multiply it by Q, and then we could use the derivative of a product, which is a formula you guys learned there, or the chain rule, or something like that, in order to calculate this revenue equation. Okay, so R is equal to that. So that's really the difference. And so now for the monopolist, the change in the profit equation as we change the quantity is going to be equal to, and remember our general description for the change in revenue as we change quantity is the marginal revenue. And then we're going to take the derivative of the total cost function, and we'll get the marginal cost function again, and we'll say, now we want to find out, and this is still the profit function. It would look a little bit different, but it would still have a peak, and we'd still be looking for the Q that satisfies that peak. So we'd also want to set that equal to 0. And we get this sort of more general description, which is the monopolist will choose, so the quantity where marginal revenue is equal to marginal cost. That's a more general description. Now, I also want to point out that really what's changed here is marginal revenue, right? And the competitive firm is a special case where marginal revenue, this is marginal revenue for the competitive firm. So we could likewise use the same description for the competitive firm. So I'll just put, for the competitive firm, P is equal to marginal revenue. Okay. So what you're going to see in a lot of these problems that we're doing is that really the big difference is that the form of revenue is changing depending upon the ability of the firm to have influence over the price of its product, and that's called market power. So the reason why the monopolist solution is different has nothing to do with the behavioral assumption of the monopolist. The monopolist is behaving exactly the same as a competitive firm would. The only difference is the monopolist has market power, and therefore its marginal revenue has a different form than the competitive firm's marginal revenue. So it's going to choose a different quantity for that reason and that reason only. But they're still both trying to maximize profit, and they do it in the same way. The math and the description of the behavior, everything's the same, but the revenue function's different. So that's the main issue. So does anybody have any questions about that? Questions? Okay. So so now that we know that the marginal revenue is different, I want to spend a little bit of time talking about the marginal cost, because what we saw in our last problems that we were solving when we were going over the homework, and what I told you guys before, is that the marginal costs for the monopolists and the competitive firms can look different. And so now that we can compute the marginal revenue for the monopolist, the real question is, for most of our problems, what's the marginal cost going to look like? And this is where you kind of like begin to deepen your understanding a little bit of what it really means to be a monopolist. So I want to ask you guys a question, and I'll put it in the chat. What does a monopolist look like? And we'll start there with that question. So anybody want to give me a description of a monopolist? Now I'm trying to get you to guys to be, this is where I said, you want to use your imagination. Give me a intuitive, non sort of mathematical, like if you close your eyes and think, okay, I want to visualize a monopolist. What does your monopolist look like? So now I'll limit my answers or responses to people that have mics. So if you have a mic, raise your hand. I know there are lots of you guys that have a mic. Okay. Okay. So let's talk to Jack first. So Jack, what do you? Okay, so tell us, what does your monopolist look like?
I know it's not a monopolist, like a monopoly, but I'll probably go with Google.
Okay, so why does Google, like when you close your eyes and you think, who's a monopolist out there? Why do you think Google?
Because everyone knows it. Like whenever you refer to like searching something, you immediately think of Googling something rather than like using Bing, Yahoo, or any other search engine or anything like that.
Yeah. Okay. So that's a good answer, because it's like omnipresent, right?
Yeah, it's like when you have like you're using a Band-Aid instead of a bandage.
Right. Okay.
Right.
So there's some idea with like market dominance because of the name recognition of the company.
Yeah.
Okay. And I'll try to push you just a little bit further if you want to. So when you see Google in your mind, so you said, oh, it's on the tip of the tongue, but when you see Google in your mind, what does Google look like? If you're going to draw a picture,
man.
if you're going to draw a picture of Google the monopolist, what would it look like to you?
It'd be like the Greek god of web browsers. You're like
Okay.
the Zeus of web browsers, yeah.
Oh, the zoo. Okay, I think that's good. Not like a puny little tiny.
No, it's no Apollo.
And
It's Zeus, yeah.
but it's okay. Okay. All right. So let's go on to Noah. You had your hand up, Noah. Why don't you tell us who's your give us a description, a visceral, a gut level description. Your monopolist. What does your monopolist look like?
Mine was Band. Whoever said that mine was Band-Aid.
Oh, Band-Aid. Okay.
Yeah, I don't know if that was
Sorry,
like.
bro.
So what does Band-Aid
good.
what does Band-Aid look like to you?
It's colossal Zeus.
Oh,
as-
okay. We'll go back to the Greek god thing. Shouldn't we do
Yeah.
some Nordic
Oh,
gods
oh.
or like expand the pantheon a little bit?
It's like the Odin of its category.
Okay.
Big guy.
Big guy. Okay, what about you, Daniel? You want to tell us about yours?
Like what mine looks like, or what company I was thinking of?
Well, you can name a company if you want to, but I'm looking for like, you know,
I was thinking of like a bully that's like pushing everyone else out of the market.
a bully. Oh,
Yeah.
okay. And
Going big and strong. There's
yeah.
not anybody else.
Yeah, so I think you guys so does anybody, so we've kind of established, like, most of us had this idea that the monopolist is like this giant I am Monopoly, right? This big huge company. I'm Google, right? And this massive, Andre the Giant, I don't know if you guys would pick anybody else, but like the Mountain, this big thing, right? Does anybody have another description of a monopolist that's not like I'm a huge, massive thing? Okay, Ivan, you raise your hand. Okay,
I was just thinking like a firm, not necessarily like a huge firm, but someone that like sets their quantity or price lower than everyone else's to capture the market.
Right, and so like, but maybe they would likely, if they were getting all the market, they would be big. But would you have like? I'm looking for another description, because I like a lot of people would describe that as Walmart is like a monopolist in retail, and they get that by the. Do you guys remember they used to have the ads with the smiley face guy that would knock down the prices? And the smiley face guy really, is like destroying local business. He's smiling, but but what I'm looking for is a different sort of description. Like, that would still be like a big guy, like, right, or girl, anybody else? Okay, so we have Greg has the robber baron. Okay, looking businessman, right? Okay, so I want to give you guys a different idea, and this is what most monopolies really look like. Okay, they're a bunch of tiny guys that band together. They're like the minions, right? So yeah, so think of all the minions, and why can the minions get things done? Well, it's because they all coordinate activity together. All right, and so Jin Kao says it's having no other choice, and that may be true. I'm not saying any of you guys have a bad idea that it's like big, but it's normally not like some big huge gigafactory. No, it tends to be a lot of small production units, but they're just managed in coordination with one another. Okay, so if you think about historic examples of monopolies, it's U.S. Steel or Standard Oil. And when I say Standard Oil to you, you probably think, oh, well, Standard Oil is this huge company. But really, Standard Oil was a bunch of small producers, meaning like individual oil wells here and there, and collectively they would all pump a bunch of oil, but that's not what gave them their market power. What gave them their market power was that they were coordinating their prices. And I'm only going to use these terms descriptively, because if you're going to use them analytically, you would have to be really precise about what you were saying. But to get you the idea, they were basically price fixing. It was a bunch of little guys banding together saying, we're going to support each other, and we won't sell our oil for less because we don't want to, compete against each other. So, and I would even say in the case of Google, though I wouldn't, press this, point too hard. But Google, if you really think about it, it's a bunch of servers, and obviously they're running this search engine technology and whatever. But the servers, in principle, and I don't know that Google owns all its own servers. I know it owns a lot of servers because they do things where they can get their ping to be better and whatever. But the main point is that all of those servers, they could be independently owned, but as long as they're coordinating in some way, then they can gain some special advantage. And I'm not sure, again, like Google is the best example, even though it's something that a lot of people, it comes to mind that Google has something like a big market advantage in search. And I'm not going to say that that's not true. But I would probably argue that really what makes, and you guys know this, right? What really makes Google dominant in search is that they have a better product. They have better service. You want to actually find the answer to your problem. Now, sure, you're going to get like 4 ads at the beginning or more maybe, and have to scroll down. But with reasonable certainty, if you put in, a few common search terms that have to do with the thing that you're interested in, and you put it in Google, it's going to show up on the first page. That's customer service. Monopolists don't normally compete on the basis of who has the better service. You go to some other search engine like Bing. I don't know if you guys have ever done this, because I tried to use Bing because it comes up, Microsoft products or whatever. But I put in like common search terms in Bing, and I just get garbage, and it's frustrating. I'm not saying that if I dug through the search responses, I might exactly get, at some point what I want, but that's a hassle. So monopolists aren't competing on the basis of, who offers the better customer service. Rather, monopolists are coordinating to dominate a market. And the reason that's important is because when we're talking about the marginal cost function, and I'm going to go ahead and go back to the whiteboard right now. So remember that the sum of the marginal costs in, among firms that are not coordinating is the competitive supply. Okay. And now, when monopolies, form, then the sum of the marginal cost among and I'll put units of production, okay, which would be the same as if they were firms independent of one another, is the monopolist marginal cost. So does everybody understand what I'm getting at? Basically, what I'm saying to you is that the supply function is the monopolist marginal cost function. And the only difference is that in the case of the monopolist, it's the marginal cost function because that's the way that the monopolist would deploy its units of production if they were coordinated to minimize its overall costs. Now, I haven't actually gotten there yet. And I'll just put it here, and it's, yet to be proved, right? So I'll put here that it turns out that and I'm going to call it the joint marginal cost function, and it's joint because it's among the various production units. The joint marginal cost function is the monopolist's way of coordinating production among its various production units and I'll say, in other words, it has multiple factories, right, to minimize its overall costs. Okay. So that's something that is, this is a subtle statement, and if it's confusing and it takes you guys a little while to digest it, that's fine. And I would just say for a moment, stick a pin in it, and then we'll come back to it, because honestly, there's no way for me to properly demonstrate it for you in the context of this class, because it's more calculus, and it requires some more advanced tools in calculus. But even with using the simple tools of calculus that we now have, we can almost get there. We can almost get there. We can see the direction that the calculus is going to point us, and I'll do that for you really quickly, just so you guys kind of get the idea. So if I was a monopolist, I would have, and I had multiple units, I would have a total cost, which was my total cost at factory 1 plus my total costs at factory 2, right? And I would be dividing production between them. So I would have some production here, and I'm going to write that as little q1. So this is the total cost of factory 1 is a function. This isn't multiplication. This is a function of the quantity that I produce, and at and also the quantity that I produce at my other factory. Okay, but then I'm going to point out, right, that it's true that my total output has to be right. So I can rewrite this as TC of Q is equal to my total cost at my first factory plus, right? So now notice that I can write Q2, right, as big Q minus Q1. Okay, right. So if I was going to try to minimize this, so now we have the same sort of strategy that we had before, but now the idea is that we have some function, which is our total cost, and we're looking for the minimum point of that. And so if this is our total cost function, and this is the total quantity of output, then again, how would we identify this quantity here that corresponds to the minimum point of this function? I'm assuming that's the minimum point, right? So this would be our Q that minimizes our total cost of production, right there. So again, it would be the same strategies. We would look at the slope of this function and say, well, here the slope is negative. It goes to 0 at the minimum, and then it becomes positive again, right? So remember, and I'll try to draw it the best that I can. What we're looking for is that's a tangent line with a slope of 0. So we're looking for where the slope of this function, which remember is described by the derivative, where the derivative of that function is equal to 0. Well, so now we can do the same thing that we did before and look at dTC dQ. But the thing that I want to kind of show you, and this is why I said that the calculus, what I'm doing now is a little imprecise. But notice that the way that I've written these two versions of this is Q1 and this is Q2. Well, if I know I'm going to produce a certain level of output, then I either have to produce it at factory 1 or I produce it at factory 2. So if I look at the change in the production of just Q1, it's going to be the same as the change in the production of Q2 and my total quantity. So I've expressed basically the big Q as some sort of target, and I'm going to change Q1, which is going to implicitly change Q2. The only difference is that we enter with a minus sign because every time I produce 1 unit at factory 1, I'm producing 1 fewer unit at factory 2. So, and like I said, this is a little bit mathematically imprecise, but it gets the idea. So we know that the sum of the changes is the change of the sum. So I can take these changes, and for those of you who don't have calculus, remember, this is just the change in total cost as I change the quantity. So I'm going to change the total cost at both of these units. So I can write and I could do it again. Now I'm changing the total quantity, but by shifting Q1 either at factory 1 or factory 2. So this ends up being DC1 divided by, and I could write DQ1, and that would be fine. But I'm not going to do that because, like I said, I'm kind of changing the quantity implicitly. So to make the point more clear, I'm just going to put it as DQ. But over here, I'm going to put DC2 divided by DQ. And I'm going to implicitly note that it's entering with a negative sign. So I'm going to change that to a minus. And then I'm looking for where that derivative gets to 0. Okay. Well, there we go. And I think that at this point in time, it's fine. I can say, well, DC DQ is equal to, I'm just going to write this as the marginal cost at factory 1 minus the marginal cost at factory 2. And I'm looking for where those things hit 0. And this gives me a rule, which is that if I'm trying to minimize my costs, then my marginal costs at each of my factories should be equal. Okay. And well, I suppose I'll put that on a separate line because this is the main point right here. That the marginal costs are equalized. So this is kind of, you know, a little bit subtle and profound. Okay. But it has a special name. This is called the Equi marginal principle. And basically, it says when you're trying to minimize the cost of something, you want to equalize the marginal costs at each of the production units. And this makes perfect sense. And Equi marginal principle has applications beyond just figuring out what the monopoly marginal cost curve is. But if you think about it, right, if I was producing such that my marginal costs were really high at one of my factories, and I'm a monopolist coordinating activity, right, and it was lower on the margin at another factory, then why wouldn't I shift some of the production here? Because, you know, we have diminishing marginal productivity. So my marginal costs can be lowered by producing less at one of the factories and raised by producing more at the other factory. So you can see there would be an immediate savings, right, by reallocating some production to the factory with the lower marginal costs, right? So I don't know if you guys like my little hand gesture, but that's the general idea. The thing that's profound about it is that this is what ends up happening in competitive markets too, through the price mechanism and what you would call Adam Smith's invisible hand and all that other stuff, is that competitive firms aren't coordinating with one another, but because they're competing with one another, what ends up happening, right? If one competitive firm has a really high marginal cost because they're using the same technology, producing the same good, and they got lots of customers, then the other one that has a lower cost on the margin, right, can offer a lower price and attract some of those customers, and that will cause the adjustment. So the interesting thing is, in the case of monopoly, you've got a manager who's intentionally shifting production between the different production units to equalize their marginal cost, to minimize the overall cost of production. But in competition, where you have uncoordinated activity, you end up getting the same result. So the conclusion there is that monopolists minimize costs, and so does the competitive market. So we get back to this idea that I was telling you about before, that the sum of the marginal costs is also it's the competitive supply curve, but it's also the marginal cost curve of the monopolist. So when we get together next time, so next Tuesday, then well, I guess we're gonna have more than a week, but you guys can work on those last problems on Monopoly where you're adding up the marginal cost curves. If you go back to the lecture that we did before, it'll give you some hints on how to do that. Again, if you're careful with the algebra, you won't have any trouble. The difference is that the constants are different for the different marginal cost units. So the problem's a little bit mathematically more complicated. Okay. So do you guys have any questions for me? There was something in the chat. Yeah, I know. Yeah, so we'll skip spring break. I know, tears. But we'll come back the week after that. Okay. So for now, finish up Monopoly, and I'll see you soon. Okay. Bye, everybody.